All right, welcome back. Here's another video that should help you move through your self-paced unit here. In the last video I talked about, I kind of looked at diagramming some molecules a little bit. We're going to go a little further into that, and I apologize in advance if my drawing with my pen is not very good yet. The last time I showed you what some molecules, like if I took hydrogen, okay, and I mix this with another hydrogen, and then I make the element called H2. Okay. Well, last time we talked about how they need to bond and what they do to bond. So we know that if I look at my periodic table, I see hydrogen is in the first row, which means that it has one valence electron. So it has one electron, okay, out here floating around in that shell. And I'm not going to draw the shell. You can, okay? And then over here, this hydrogen has another valence electron. But we know in the first shell from that chart we talked about, hydrogen really needs to have two electrons to be stable. So what these two things would do, okay, is they would combine this electron here with this electron and share them, so now it looks like they both have two. So I would have a hydrogen and another hydrogen, okay, and the way I show that bond is by one dashed line, meaning that they are sharing one set of electrons. So now I have my molecule that is called H2. Okay. Well, if we go on here, we're just going to pretend that these two green balls are oxygen. Okay. And if we look at our periodic table, we see that oxygen is in group 6. Okay, from the left, remember we skip over the transition metals. Group 6, so we know that oxygen has 6 valence electrons. So there are 6 little dots floating around each of these oxygens. Well, in order for oxygen to be stable, we know that this would be the valence is the outer shell. So we know that they need to have 8 to be stable. So one thing I can do is I can draw a circle. So there's one, and then here's another one where they could share. So now let's count them. If this oxygen had 6 and now it's sharing 1 and 2, now it has 8. Okay, and it likes to have 8, and the same is true for the other one. So this diagramming this molecule would look like this: 2 oxygens. Okay, and that's called a double bond. Feel free to stop this if you need to at any time. This table, I'm going to fill out 2 of these for you, and then I'm going to let you do the rest. Okay. So we know that hydrogen, since it's in group 1, it has 1 electron total. Okay, and that means that in its outer shell, it has 1, because the outer shell it'd be the first shell, and the most I can have is 2. So how many electrons does it need to fill its shell? Well, it needs 1 more. So it has 1 valence, but it needs 1 more to be. Okay. Helium, this is a tricky one, because helium, if you look, it is in group 8, but it is a lot like hydrogen in the fact that it has 2 electrons. So it has 2 in the outer shell. So how many does it need to fill? 0. Helium is a noble gas and does not need to borrow or share electrons. It does not bond with things easily because it is so stable. So the last one I'll help you with is carbon. And if I get out my periodic table of elements, I can see that it is in group 4. So it has 4 electrons, which means that it has 4 in the outer shell, and it needs 4 more to become stable. Okay, now you have the sheet in front of you, or you will. You need to find this sheet and finish filling out this table. Then come right back to this video and keep moving on with me. Our final thing, now I'm going to show you how to do 2 of these. This is kind of your task after this. So the first one is hydrogen peroxide. Many of you know what that is. Okay, it's used to clean wounds. Doesn't feel very good when you're little. And if I were to draw a diagram of this, okay, here's a really good example up here that you can always fall back to, okay, of what that would look like. I'm going to start with oxygen first. So there's one. Sorry, my circles aren't very good. And then I'm just going to surround with my H's, and it doesn't really matter where you put these. I just like to work in straight lines. Okay. Well, now I'm gonna save my hydrogens for the end, and you'll see why. All I need to do is show where the bonds are going to be. So let's just start here. We know that oxygen has 6 valence electrons, and it needs to have 8 total to be full. So if we go 6, and then we count the bond as 1, 7, well, I know that hydrogen only needs 1, needs to share 1. So if I put a line here, and a line here to show the bonds, now I can go through here. So hydrogen has 1 plus 1, 2. We're good. Check. Okay? Oxygen has 6, 7, 8. 7, 8. Check. Okay? Oxygen has 6, 7, 8. Check. And then hydrogen has 1 plus 1. Check. And now I know that my diagram is completely right. Okay, the last one we're going to do, once I erase this, and you're kind of lucky, I'm giving you a lot of help on this. Okay, is NH3, which is also known as ammonia. Again, I'm going to start with the N in the middle, and then, like I said, I like to work top to bottom or left to right, just because spatially that's kind of how I think. So I draw, well, that's a really wide H, I apologize. Okay, so there it's set up. And I know that nitrogen has 5 valence electrons, so it needs 3 to be full. Well, that seems easy. 1, 2, 3. There's my 3 bonds. Nitrogen has 5, 6, 7, 8. Hydrogen has 1, 2, 1, 2, 1, 2. Check. We're full. If you have any questions, please do not hesitate to come ask Mr. Hugh. Email him, or use your magical white box and look it up on your own. Nice job. Thank you for watching.